In this class we are going to see some questions from the chapter Gravitation. A stone thrown upwards takes 3 seconds to attain maximum height. Calculate initial velocity of stone, maximum height attained by stone, and net displacement when it comes back. First equation of motion, V equals to U plus GT, where G equals to minus 9.8 meter per second square, because the stone is going in the upward direction, which is in the opposite direction of acceleration due to gravity, and T equals to 3 seconds. Since after reaching a certain height its velocity becomes 0 for a moment, so its final velocity V equal to 0, U minus 9.8 into 3. By this we are getting U equals to 9.8 into 3, which gives the value of U as 29.4 meter per second. Now for the second part, by using twice GH equals to V square minus U square, we are getting H equals to V square minus U square upon twice G. H equals to 0 minus, in place of this U square we are substituting the value of U here, which we got here, 29.4 into 29.4 upon 2 into minus 9.8, as the stone is moving in the upward direction. Again we can write this 29.4 as 9.8 into 3, so that this 9.8 will be cancelled by this 9.8, and by this 2 we can cancel this as 14.7. so we are getting 3 into 14.7, which gives the value of H, that is the maximum height attained by the stone, as 44.1 meter. Now the net displacement, it will be 0 as the stone comes back to its initial position. Now we are coming to the next question. A stone is thrown vertically upward with an initial velocity of 40 meter per second. Taking G equals to 10 meter per second square, find the maximum height reached by the stone. What is the net displacement and the total distance covered by the stone? Again, the initial velocity U equals to 40 meter per second, it has been given to us. As we know, after reaching a certain height, the velocity of the stone becomes 0, so final velocity V equals to 0 meter per second. Acceleration due to gravity, G equals to minus 10 meter per second square, as the stone, when it is moving in the upward direction, it is moving in the opposite direction of the force of attraction, so we are going to take it as minus. Maximum height H. Now by using this equation, V square equals to U square plus twice GH, we are getting H equals to V square minus U square upon 2G, or H equals to 0. When V equals to 0, it will give us minus 40 square upon minus 2 into 10, as the value of G is minus, negative we have taken, which gives the value of H as 80 meter. Now the net displacement, it will be 0 as the stone comes back to its initial position. Now the total distance covered by the stone will be 80 meter in the upward direction, and after reaching a certain point it will come back again by traveling a distance of 80 meter. So the total distance covered by the stone will be 80 meter plus 80 meter equals to 160 meter. Suppose that the radius of the earth becomes twice of its original radius without any change in its mass, then what will happen to your weight? Now according to universal law of gravitation, the force of attraction between any two objects F equals to capital G, capital M, small m whole upon r square. On earth it is the same force by which we have been attracted towards the center of the earth. Therefore, if our weight is W, then it will be given by W equals to capital G, capital M, small m upon r square. When the radius of earth becomes twice, then our weight will be a new one. If we denote it by W dash, so W dash equals to G, capital M, small m upon square of 2r, which gives us 1 upon 4 bracket capital G capital M into small m whole upon r square. Now this value is of W here. So we can write W dash equals to W upon 4. So we can say that our weight will become 1/4 of the previous one.